Okay, today we're going to look at section 1.3 on solving equations. Section 1.3 on solving equations. First thing we have to go through is properties of equality. These shouldn't be anything new to you. Should have had them in ALG 1 and in geometry. And properties of equality, that means you're going to have an equal sign. And these are for any real numbers. And remember, I use a double bar R for real numbers. That's any number on the number line. For any real numbers A, B, and C. First property is the reflexive property, and the actual name is reflexive property of equality. We're just going to abbreviate it to reflexive property. And the reflexive property says any number or quantity equals itself, like A equals A. And then examples, like if I said 5 equals 5, that's the reflexive property. I could use a quantity like x plus 7 equals x plus 7. And they may or may not have parentheses around that. They could use a different operation. They could say 2 times 3 equals 2 times 3. And notice these are in the same order. X plus 7 equals x plus 7. 2 times 3 equals 2 times 3. That's reflexive. It's got to be in the same order. Symmetric property. And again, it's symmetric property of equality, but we're going to abbreviate this symmetric. And it says if A equals B, then the symmetric property says you can turn that around, then B equals A. And it can be quantities also. Like if you said if 2 times 4 equals 8, then 8 equals 2 times 4. Notice the 2 times 4 is in the same order. These just, the 2 times 4 equals 8, and 8 equals 2 times 4. They change places around an equal sign. Okay, so that's the symmetric property. Transitive property. And the transitive property of equality, transitive property has 3 equal sign. That's one way to tell. And it says if A equals B and B equals C, then A equals C. And again, you can have quantities. So if I said if 3 plus x equals 7 and 7 equals 2 plus 5, then 3x plus 1 equals 2 plus 5. The 3x plus 1 is like the A, the 7 is the B, the 2 plus 5 is the C. Okay? So if A equals B and B equals C, then A equals C. That's the transitive property. Okay, another property that you need to be able to solve equations is substitution. And you've used this a bunch already in ALG 1 and geometry. Substitution says if A equals B, then A may be replaced by B, and B may be replaced by A. An example of substitution: if Let's say if 6 plus 3, that quantity times x equals 36, then 9x equals 36. So if you put the 9 in for the 6 plus 3, then you've substituted it in. Okay, and that is substitution. Okay, then let's look at a couple of examples. The author will give you directions. It'll just say name the property. Name the property. An example, let's say I have a minus 2.03 equals a minus 2.03. Okay, it's the same thing on both sides. Okay, it's equal to itself. That's reflexive. Another example, if 9 equals x, then x equals 9. They change places around an equal sign, and that one fits. If a equals b, then b equals a. That is symmetric. If I said like 5 equals 5, I think that was in one of our examples. Any number equals itself. That's reflexive. And last example, if 1 plus 4 equals 5, and 5 equals 2 plus 3, and 1 plus 4 equals 2 plus 3. So name that property. Okay, and that should be if a equals b and b equals c, then a equals c. Notice the 1 plus 4 is the same order, the 2 plus 3 is in the same order, and that is transitive. If a equals b and b equals c, then a equals c. Okay, then the author is going to take you through solving equations. That's what this section is mainly about, on solving the equations. And the main thing there is steps to solve equations. I would always think about to combine like terms. If there's anything you can combine on the left side of the equation, anything you can combine on the right side of the equal sign. Okay. Think inverse operations. That's a key. Okay, like if it's a subtraction, then you may want to do the inverse and add. If it's multiplication, you may want to do the inverse and divide. Okay, and that brings up that you're going to use, when you're solving these, the addition and subtraction, properties of equality, and we're also going to use the multiplication and division. You can abbreviate it, multiplication and division properties. It's okay to abbreviate that. You're also going to use the distributive property. Okay, that's another one. So I'll list that in here. Okay, so let's look at an example. And usually the directions will just say solve. Okay, and let's say m minus 5.48 equals 0.2. Solve for m. You want to get m by itself on one side of the equal sign. You can't combine any like terms, so do the inverse operation. Always think inverse. And on this, you got to line up the decimal points. So you need to add the 5.48, line up those decimal points, bring down the m. The minus 5.48 5.48 plus 5.48, that would go to 0, and then make sure you have the decimals lined up and you go 5.68. And then you should be able to check your answer, substitute back in, check it, make sure it works. And then for your grader, either highlight your answer, double underline it, circle it, something, so they know that's the answer. Okay? On the next example, let's say you had 18 equals 1/2 t. And that's 1/2 times t. So do the inverse. You can do the inverse and divide by a half. There's two ways to do this. You can divide by a half on both sides. And remember, if you take 18 divided by 1/2, you invert and multiply. So invert that, and you should end up with 36. So 36 equals t. That's one way to work that. Another way to work it is take 18 equals 1/2 t and multiply by the reciprocal. So the reciprocal of 1/2 would be 2, multiplied by 2 on both sides. So you get 36 equals, and these would reduce, and then you'd end up with t equals 36. So you can show that either way. It doesn't matter to me, whichever way makes more sense. You can think inverse operations or multiply by the reciprocal. Okay, the next one. Say you have a two-step 6x minus 12 equals 18. Do the inverse. You want to get x by itself, but first you have to get 6x by itself. So do the inverse, add 12 to both sides. And I want to see that step. I want to see your work for your notebook. Okay, equals 30, and then 6 times x, so do the inverse, divide by 6, and x would equal 5. And again, you should be able to check your answers. You substitute it back in, at least do a mental check. You don't necessarily have to write it out, but at least do a mental check to make sure that you have the right answer. Okay, another one, multi-step. So you have 53 equals 3, and you read this times the quantity, y minus 2, minus 2 times the quantity, 3y minus 1. So this is where you are going to use the distributive property. Multiply this out. So you'd have 3 times y would be 3y. 3 times a negative 2 would be negative 6 or minus 6. Negative 2 times 3y would be a negative 6y. And a negative times a negative would be a positive 2. So you get 53 equals 3y minus 6y plus 2. Now combine like terms. Okay, so you'd have, I'm going to get a different color here. So you'd have 53 equals, combine the 3y minus 6y would be a negative 3y. A negative 6 plus 2, take the difference in the sign of the larger one, negative 4. And now get the negative 3y by itself, do inverse operations, add 4 to both sides. Okay, so you get 57 equals a negative 3y. Divide by a negative 3. And you have a positive divided by a negative would be a negative. And 57 is going there 1, and then 27 divided by 3 would be 9. So negative 19 should be your final answer. Okay, so that one's a multi-step equation where you have to use the distributive property, combine like terms, and then think inverse operations. The last part of this section, the author will have you solve a formula for a specific variable. So the directions might say, given the formula, because you do this a lot of times in math and science classes, solve for a specific variable. Okay, so in this problem, let's say I just go back to the regular distance formula, distance equals rate times time. Okay, you've got 3 variables you can solve right now. D is by itself, but you can solve for any of them. Let's say I ask you to solve for T. Well, it's rate times time, so do the inverse. And if I want you to solve for, let's solve for R instead of T. Let's solve for R, so divide by T on both sides. So the rate would equal the distance divided by the time. So if you say I'm going 300 miles to Manhattan and I'm driving at 70 miles an hour, okay, you would divide the 300 divided by, 300 miles per hour. Let's say it took you 6 hours. 300 divided by 6 would be 50 miles per hour. Okay. Another example. Let's say we do surface area. This one is surface area of the cone. We would have had this last year in geometry. Surface area of the cone is S. Surface area equals pi r L. That's the slant height plus pi r squared. That's the area of the base, the circle. And let's say I want you to solve for L. Okay, now there's a couple ways you could do this. You could, we need to get this term by itself, so let's subtract pi r squared. So you'd have S minus pi r squared equals pi r L. And then to get L by itself, you could do it in one step or two. Let's do it in one. Divide by pi r. Okay, and these would divide out, and L equals S minus pi r squared over pi r, divided by pi r. You could actually, on that one, you could factor out a pi r and then solve it that way too. That's another way to solve it. But that would be, this would be your answer. Okay? Okay. That should be enough to get you started.